Okay, welcome back to the next set of notes on trapeziums. So we have seen from the video about how the formula for the area of a trapezium was derived. So let us now put in the information that we have for a trapezium. It has only one pair of parallel sides. So in this case, BD is parallel to AC. And then the distance for BD and CD, they are not the same. Otherwise, it would be a parallelogram already. So AB is not parallel to DC. And then we also saw that, let me just do a quick recap. Interior angles, parallel lines, A plus B, they are given to be 180 degrees. So our reason is interior angles, parallel lines. Similarly, our angle C and angle D also gives us 180 degrees. Okay, so here we have the diagram of what was same as the website. So we rotate that trapezium, the duplicated trapezium, you join them, you will form a parallelogram. So what about the area of the parallelogram? We know that it's going to be A plus B multiplied by that perpendicular height, h. Then what about the area of one trapezium? Then it will be half times A plus B times h. So this is how we usually say it, where A plus B will be our sum of the parallel sides of one trapezium. Okay, so that's over here, referring to the same thing. So we can apply that formula directly to find the area of these trapeziums. So using the formula, can keep referring to it first. Our area for the first one, half times the sum of the parallel sides. You have to be able to identify that the parallel sides will be 8 and 5. So 8 plus 5. Then the perpendicular distance between them will be our 6 units over here. So 3 times 13, that gives us 39 square centimeters. That's for part A. Then in part B, again half times the sum of the parallel sides. You can see that it is 3 and 7. Perpendicular height will be 4. So 10 times 2, 20 square centimeters. And then the last one, very weird looking trapezium, but it's okay. So half times the sum of the parallel sides, we have 11 and 5. Perpendicular height will be 9. So 8 times 9, 72 square centimeters. Direct application of the formula. Please note that the formulas are not given to you during the test and exams. You need to memorize it. But once you have derived it by yourself, you understood how it is derived, then the memorizing is not too difficult. So exercise 2, try it yourself. Okay, this time you have to work backwards. They are telling you that the area is 5.5 square meters. Find this distance. So what is this value of AD such that half multiplied by AD plus 3 times 2.5 gives us 5.5. So practice your algebra for that. Next one, exercise 3. Again, they give you this time they give you the parallel sides, 5 and 9, but they do not tell you the height, CE, but they give you the area. Okay, so I will try this with you. Once you understand the question, come up with a plan. It is definitely related to the formula for area of a trapezium, given to be half times the sum of the parallel sides, 9 plus 5, multiplied by the perpendicular height, which CE, we don't know what it is. And this area is supposed to be 42. That's provided in the question. We just want to find CE, so we need to get rid of all that extra stuff. Let's get rid of the half first. We multiply it by 2. We multiply this by 2. Now we end up with 9 plus 5 is 14. CE equals to 84. We now want to get rid of that 14. We divide it away. we are just left with CE. 84 divided by 14, that gives us 6. So 6 meters. You can use this same approach for your exercise 2. Exercise 4 now. The wall of the bathroom. Okay, so we try and apply it to some real world context. And they tell us the area is 18. We want to find the length of AD. So this over here. Definitely related to area of a trapezium. Half times the sum of the parallel sides, AD, we do not know where it is, plus 3 units, multiplied by 4.5. And this is supposed to give us 18. We want to find AD. Let's get rid of the half. Multiply by 2. Now we have AD plus 3 times 4.5 is 36. We want to get rid of the 4.5, so divide it away. We now have AD plus 3 is 36 divided by 4.5. That's 8. So something plus 3 is 8. Carry on here. Something plus 3 is 8, then that something must be 5. Okay, next one is to find the area of the rectangle. Find the area of triangle ABC. Let's identify it. Okay. As a percentage of the area of triangle ACD compared with this area. So we are dealing with areas of triangle. Definitely we'll use half times base times perpendicular height. Now, is there a relationship between these two triangles? So you should notice that they share the same perpendicular height AB. So if AB is the perpendicular height, then we want to use the base to be AD as well as BC. Or you can just, since we already know AD is 5, you can just use any way you like, as long as it's mathematically correct, to find the area of both triangles, put it in percentage. So do this now. Okay, let's try exercise 5. We have got a trapezium and a parallelogram. They tell us that the area of the trapezium. Okay, so area of trapezium, straight away we can write down the formula already. Half times the sum of the parallel sides, 13 plus 5 times the perpendicular height h. They say that it is twice, so it's 2 times of the area of the parallelogram. Okay, area of parallelogram, we've got a 6, we've got a h. So 6h. Form an equation, done. Find the value of h. Okay, so let us now get rid of some stuff. We can divide both sides by 12. So very conveniently, you're left with h. So h will be half 13 plus 5 is 18 times 8 over 12. So work all this out. You get 6. Okay, so for the rest of the lesson, if there's still time, as well as your weekend homework, is to complete this set of notes. There's not much left already. Okay, just until page 5.